Hello, and welcome to Foundations for Algebra, Unit 3A, Lesson 5. Today, scholars will convert terminating and non-terminating decimals into fractions. So what do I mean by terminating and non-terminating? So terminating just means ending. So 0.25 is a terminating or ending decimal. 0.33333 forever is non-terminating, unending. So that's all I mean by terminating and non-terminating. So how do we convert terminating decimals into fractions? Well, that's real easy. We look for where the last digit is. In this case, 0.25, the last digit is in the hundredths place. Two spaces past our decimal. So we're going to put the 25 over 100 and then reduce it. So 25 over 100, and I know that 25 goes into both, so I'm going to divide top and bottom by 25, and it equals 1 over 4. Well, what if it's just like 0.5? Well, the last digit is in the tenths place, so we just put 5 over 10 and then reduce. So we have 5 over 10, and I know those both can be divided by 5. It is 1/2. And then if we have something like this last one where I have 0.125, the last digit is in the thousandths place. That's 3 spaces past my decimal. So I'm still going to put 125 over 1,000 and then reduce. 125 over 1,000. I know those both divide by 5. So 125 divided by 5 is going to be 25. And the 1,000 divided by 5 is 200. Okay, and obviously those still both divide by 25. So when I divide those both by 25, I get 1 over 8. It's that simple. I could have divided by 5 again, then divided by 5 again, but I knew that that one would work that way. So I get 1/8. Not that hard, but we have terminating decimals. We just need to know which place to put them over. So what if we have a non-terminating decimal, like 0.33333 forever? So we can use some things about these to find the answer. So first we're going to set x equal to whatever our fraction is. And then we're going to multiply x by 10 to get 10x equals 3.33333. So if I do 10x divided by 10, I write it this way because it's a little easier to see. 10x equals 3.333 ... x equals 0.333 ... I'm just going to subtract these two. Well, 10x minus x is just going to be 9x. 3.333 forever minus 0.333 forever gives me a 3. So now I'm going to do x equals 3 divided by 9. I divide by 9 on both sides. Now I know I need to reduce that. 3 over 9 is equal to 1 over 3. I can divide top and bottom by 3. By the way, do not put this in your calculator and then reduce, because it will say, oh, look, it is 0.333, and you'll end up back at your decimal. You have to do this by hand. Okay, so that wasn't that hard. And you knew that, right? You knew 0.0333 was 1/3. What if I have a number like this? I have 0.454545. That one I don't know. Again, I'm going to have x equal to 0.454545. Then I'm going to have 100x equals 45.4545. Why am I doing it that way? Because I want to be able to get rid of or cancel out that 0.4545. So x is 0.4545. Let's put the dots. And 100x is 45.4545 ... When I subtract here, I get 99x equals 45. Because the 0.4545 forever cancels. Again, I'm just going to divide both sides by 99. I get x equals 45. Ooh, that was the wrong number. 45 over 99. And that doesn't reduce because, oh, it does reduce. They both are divisible by 9. Sorry. Divide by 9, top and bottom. So that gives me 5 over 11. But I know that that's my answer, 5 over 11. And to check this, I could just put 5 over 11 to a calculator and make sure that I get 0.454545. Well, what if I have something like this, where the first digit doesn't repeat, but the rest of the digits do? In that case, in order to work this, I need to do 10x and 100x. In this case, I have 100x equals 46.6666. And 10x equals 0. No. Sorry. 4.6666. Again, I'm just going to subtract. And I get 90x equals 42, because 46 minus 4. So then, again, I'm just going to divide both sides by 90. X equals 42 over 90. Well, those definitely are both divisible by 2. And that gives me 21 over 45. So doing that simplification at the end is probably one of the most difficult parts, but that's okay. So what patterns do you see? When one number keeps repeating, something like this, we end up with a fraction that's something over 9. When two numbers keep repeating, we end up with a fraction that's over 99. And when the second digit keeps repeating, we end up something over 90. Okay? So it's not real hard. In this case, it would be 4 over 9. In this case, it would be 51 over it. In this case, we would have 75 minus 7, which would give me 68. So it's not that hard. Just make sure you pay attention to these patterns and then reduce. Okay, go ahead and try your classwork, and I will see you in class.